Okay, I'll start the presentation by thanking first to the author of the paper who actually agreed to swap the presentations because I have to catch the plane this evening to go back to Stuttgart. And I will also express my appreciation for having this opportunity because we have been explicitly, so to say, if you want to use the word pushed, to seek for the collaboration with other projects in the area of security, pushed by the Commission, because some of the tools which have been developed in some of the projects could be, or even should be, used in other projects. So in this particular case, we are talking about the Smart Resilience project, which is a project dealing with resilience, which puts together the question which has been also raised during these presentations here, that if you have a problem or a threat which is looming to your infrastructure, be it the type of infrastructure you use in Scout or others, you might be interested not only in what are the risks and threats, you might be also interested to know what will happen to that infrastructure after this risk materializes. This is in the basis of the concept of resilience, which then wants to say and to look at the behavior of the whole system. Nowadays, it is not only one infrastructure, but like in Smart Resilience, an infrastructure of infrastructures. So, for instance, in Smart Resilience project, we look at Smart City, which in itself has a smart energy supply. We don't have the pointer here, but you can see smart transportation structures, like smart airports, for instance, smart protection systems, and even smart production systems. I mean, you just think that production systems like refineries, like chemical plants, like power plants, are nowadays equally smart as many other systems which were called exclusively smart used to be 10 years ago. So when you have such a situation and you actually see what happened, what you actually want to know is, as I said at the beginning, if you have an adverse event, be it a terrorist attack, cyber attack, extreme weather, what will happen to your infrastructure or your infrastructure of infrastructures? It will, of course, in the general case, suffer some damage, suffer some problem. And you would, first of all, like to know how far it's going to go, how deep this problem is going to affect your functionality or operation of the structure. After that, you would like to see how fast and how comprehensively are you going to recover from this situation. Normally, in a nowadays world, everybody is expecting that after an accident, after a problem like this, the whole system starts behaving better. So we talk about transformative and adaptive resilience. So this whole thing here is a very nice representation. People can intuitively understand it. And everybody understands that on this horizontal line, on x-axis, you have time. But what do you have on the y-axis? That is something which is much more difficult to assess. If you are talking about an electrical network and you talk about, I don't know, number of megawatts delivered or whatever else, you might be lucky. But even then, you might start thinking, is the number of megawatts everything? Do I need also frequency, like the accident which we just had, and similar? So you see that the functionality which is on the y-axis is something which can make a lot of troubles. So in Smart Resilience project, we have actually looked at a complex system of infrastructure of infrastructures. So Scout infrastructures could be equally one of these infrastructures which go across horizontally over infrastructures. And in this particular picture, you see a very schematic representation of what happens in the case, I really miss a pointer, if you have an accident happening on on an industrial site, for instance, which is in this particular case here an explosion. How after this explosion the plant itself will be affected, and how in the case of injuries and fatalities healthcare, health system will be affected by this, and the whole chain can then include all other systems like water supply, like transportation, and last but not least the whole city and financial systems. Information systems, for instance, relying on Scout type infrastructures could be equally part of this. So what we have there is the question how to assess these consequences first, which is that what you see on the left part of the slide. Then you want to know, do I satisfy some limit criteria? Am I going to supply enough people with the electricity after an earthquake, after an extreme weather, or after a terrorist attack? And that is something which depends on many factors, and that is the next thing which you like to have is to follow and monitor this. In the next instances, in the second row, you see that you would actually like to be able to model the interdependencies between these infrastructures, and to optimize all your measures which are there. How do we do it? And that is where our Smart Resilience project has proposed a solution. This solution is essentially based on is essentially based on using of indicators. So we have collected about 2,000 indicators. Yeah, having here a small problem. I apologize for this. Give me just a second. You should believe me that something should be happening now, but it does not. Okay, yes, now it starts. So we say, and we say that we want to have indicators, and these indicators are something which have to be defined and which have to use all the information available, but of course in such a way that this information is still transparent. So we have tried to aggregate it. We have created a matrix which is called resilience matrix, and it has dimensions: system, physical, information, smartness, organization, business, and phases. Starting with understanding risks, looking at the whole model, which brings you to the improved situation after the accident. In each of these cells, we have created a bunch of issues which characterize each situation, and for each of these issues, we have defined indicators. So that is something which can then be used in a complex system which does this for you. And I will switch to the system shortly just to show you the similarity with the Scout system. It's also in the choice of interface. Whoever decided to take the bootstrap type of the interface for Scout was doing the same and following the same logic as we did. So what we do there, we actually create such a series of typical scenarios. In each of them, be it on time of the scenario, of time of operation, or combined time, we look at the issues and indicators and provide calculation, of course based on indicators, which gives us an answer to the question, is the stress test for this infrastructure okay or not? This methodology has of course to be further on, so to say, adopted by the authorities and the others, and this is our next step. This is where we would like to go, for instance, also in the next Infra 01 call in August early this year. So when we do all this, what we do now on TRL 4 in this project, we would like to raise to a higher level and bring it to the situation, including the part of optimization of decision and graphical representation. Graphical representation meaning that we can cover, for instance, at this moment, 120 infrastructures, health infrastructures in all of them, and then, as I say, optimize the decision. So, Of course, the tools is there, the dissemination plan and all this, what you always have in all the project is there. But this worst case stress testing is some key message where we would like to provide a tool to the community is in the complex system, a stress test pass. Can you be happy with the current status of your flood protection, security of industrial plants or similar? So that is of course a complex task in the situation where the interdependencies are maximal. This what you see here is the direct result from the big data analysis from about 2,000 indicators which we have collected so far in the system. And of course, if you try to apply it, then you come, that's maybe a sort of a small, how's it called, exercise which we did especially for this workshop here. If you take and say, okay, let's see what's available about Scout system. We have taken Tira, just based on information which you can find in the internet. We didn't get anything from Fabrizio. It was
I couldn't.
You couldn't, yes. We know that some of the stuff is confidential. But if you take this and then you apply this whole system, and then you say, okay, I want to see what do I have in understanding risk, data tracking, data analysis, risk assessment. In the anticipate prepare phase, you look at the indicators and you look at the information which you have, you structure it as we did it here, then you can have something which then in a system provides you a sort of a checklist and says we have given the indicators in such a way that you get all for Tira and the rest the green values, don't worry. So we didn't go for bad news. But you can then say in the final phase, okay, I can follow the situation, for instance, assumed values, everything is very fictitious, everything is just an exercise. You can say, I can follow the situation, what happens in a physical attack in a sensed system, or what happens in the case of a cyber sense system in the case of a cyber attack. And this is, as I say, based on the indicators which we have more or less, to use the popular term, sucked out of our finger and gave the best educated or less educated guess for the values. To conclude, we would like to follow and pursue this issue of collaborating and integrating different project results. In our project, we have essentially 8 plus 2 types of critical infrastructures, and we are going in this autumn to do tabletop exercise for integration of different infrastructures. In July, we will have an exercise at the airport as the source of the indicators, which will involve 1,500 persons in a drill on the airport, simulated. The scenario is we simulate first the cyber attack onto the detection system, and then due to this failed detection system, people or terrorist attack can happen because people can bring in explosive and the rest, and then we simulate the whole event. So multiple risks. For us, we have extreme weather. I forgot to say it's not only your cyber and terror, and so that is where we want to go in the future. If you now look a little bit at the system, for which I will have to do a small trick here somehow. I hope it will work. Come on. Okay. So that is where you see the smart resilience system. Looks very much similar to the Scout. Hello. And then if you want to look at what happens at the page, you can of course go to the page. We have our dashboard which serves for creating this, and your cyber attack and your case here is given in one of the cases. And then if you want to know how did we get all these curves which I presented, you will get something like this, which was Tira, a cyber attack, and as I say, all the values are invented. But in the future case, we could easily, I so to say, make the example or examples more realistic. Last but not least, extreme important thing for the future in this area will be visualization from our side. That's where we work a lot with IBM Israel, and for instance with them, either for the Austrian case study, which is for instance this one, or for the for the Tel Aviv map of critical indicators, they have a lot of reasons to think about terror attacks and similar. You can then say in which phase you have a green or red or other situation. So this contribution here is just a nice invitation to work and work together in the future, and to indicate to all of you that there is something which can be used. All of the results in our exploitation plan are planned to be public, except of the data, which will remain confidential, of course. Thank you. That would be all.